Hi, Assalamualaikum. My name is Nadra Bintu Samad and I'm presenting my PGCA Plan Do Check Act, and my title is Reduction of False Call at the Automated Optical Inspection AI stage via Program Optimization and Lighting Calibration. This is for our agenda review. We have Plan Do Check and Act. Plan. The problem is data analysis from the SMT production line show a high rate of false calls at the automated optical inspection in the eye stage. These false calls frequently are caused by minor color board variations, components from the different suppliers, and should cause inspection operator to manually re-verify QuickBot, creating a severe bottleneck at the end of the line. So my plan for the solution is to optimize the AI inspection algorithm parameters and perform a complete system native regression by updating the component library templates and tuning the component threshold tolerance. The system can be better differentiate between extreme defect and acceptable process variation. For the summary of the plan, what does that needed to improve? First, we analyze the AI defect logs to identify the top three component packages causing the highest false cost, then optimize their program algorithm parameter. For the who is the person for responsible for this, SMT engineer and myself. When did we start? From 15 June until 19 June, where the first location is at the SMT production line, SMT department, and prediction of what will happen in notes. Retuning the inspection threshold and expanding the component library window will significantly reduce false rejection. Secondly, perform hardware maintenance including camera lens cleaning the RGB lighting calibration on the AI machine. The person responsible for this is the SMT maintenance technician. Uh, when did this start? 23 June until 23 June, where this happened at the SMT line production. Prediction of what will happen is consistently lighting level will stabilize image expression and prevent pseudo-induced false call. For do a small-scale pilot trial was executed exclusively on SMT line production on the primary post-reflow AI machine for 2 consecutive work weeks. The optimized AI program featuring updated component threshold for the top three high cost parts was deployed. Technician monitor the machine real-time inspection performance daily. Every every post call ticket by the machine was reviewed and logged on daily tracker sheet to ensure actual defects were still caught perfectly. The trial tracker sheets were signed off daily by the line technician and verified weekly by the industrial coach. For check after evaluating the AI performance data on line production throughout the 2 week trial, the following positive results were recorded. With significant possible reduction, the total number of false calls online 7 dropped by 50%, drastically reducing the inspection window on for the floor purpose. Secondly, zero escape defects. The program optimization maintained a 100% defect detection rate. No actual defects escape to the next process stage. And lastly, cycle time improvement. Lower postcodes reduce the manual verification time per bot, smoothing out the bottleneck and improving the overall line throughput. For the last act, the decision is to adopt and implement the full original plan across all active manufacturing line in the SMT department. Next step is standardization, implement The ultimate AI component library parameters as the global standard practice standard for all similar protect model running across the SMT productionized. Secondly, continuous monitoring. Establish a weekly review of AI data to catch any new component variation early, ensuring the extraction program remains fine-tuned without compromising quality control boundaries. Thank you.